Today we're going to talk about steps for solving by elimination. Okay, 3 easy steps to remember. Okay, eliminate, one of the variables, right? Solve for the other variable, and then plug that variable back in so that you can get the other coordinate. Remember that your solution should be in the format x comma y whenever you're finding this solution. Okay, you want to line up your equations in standard form to make sure that they match A, B, C, D. So forth and so on. Now these other letters, they're just to see different numbers. You want to make sure that everything lines up. Your x's line up, your y's line up, and your constants line up. That's what you want to make sure. So you want to make sure it's in both equations are in standard form. So they should both be in this format is what you want to do. So equation 1, equation 2. I always try and number my equations to help me stick with them. I hope that you guys do that too. I'm going to go ahead and go over to this next page. Okay. Your solutions, you have one solution that's an x comma y, right? And this is going to be your point. Whenever you have a solution, this is what we call the point of intersection. Okay, when the two lines cross, that's where they'll meet. Okay, and here, that's one, right? That's where the two lines intersect. Here you have the no solutions. This is when all of your variables cancel out and you're left with a false statement. So your statement's false. So you're lining up your equations, you're setting them equal to each other, and all of a sudden your variables disappear and you get up 6 equals 7, right? Well, obviously that's false. So since that's false, you have a no solution. And this is after you set them up, okay? Then you have IMS, infinitely many solutions, very similar to the one before. All of your variables are going to be canceling out again, but this time you're going to be left with a true statement. So your x's and y's disappear, and you're left with 6 equals 6. Okay, that's a true statement, so therefore you have IMS. Basically what this is saying when you get to this situation is they're the exact same line, okay? So let's do some practice problems here. Solve each system of equations by elimination. Okay, the first thing we want to do is set them up, make sure that they're in rows. Okay. All right, everything's set up. B's are here, F's are here, constants are here, so we're good to go. Now in this situation, we want to look at the coefficients and see if any of the coefficients, when we add the two equations, so here's equation 1 and equation 2. When I add these two equations, will any of these variables cancel out? And in this situation, we're lucky enough because this f and this negative f, they'll cancel out to give me 0f. So it's like 1f minus 1f gives me 0 f's. Okay, so now we just add straight across, straight up and down. 3b plus b equals 4b plus f minus f is 0f, or I like to say just 0, right? That goes away. 19 plus 17 equals 36. Okay? Now that we have 4b equals 36, because this is 0, we have a simple equation that we can solve for. 4b equals 36. I can divide both sides by 4, and I get b equals 9. So far, I know that b is equal to 9. So that's one part of my solution. Now, the next thing for you to do is to plug this piece in to find your other variable. In this case, I'm going to use equation 2 because that's real simple. B is right there. So I'm just going to replace b with 9 minus f equals 17. Right? So I'm going to solve for f by itself, subtract 9 to both sides. I get negative f equals 8. Right, 17 minus 9 is 8. Then, because this is still negative f, I'm going to divide by negative 1 to both sides, so I can get a positive f. Negative divided by negative is positive. F equals negative 8. So, therefore, in this case, this solution, my solution should be 9 comma negative 8. All right, let me go on to the next one. Equation number 2. Okay, again, I like to number my equations. It always helps me out. It helped me out with substitution. It's going to help me out with elimination. Okay, so I line them up, make sure my constants line up x's line up, y's line up, constants line up. And your constants should be on the other side of the equal symbol. If they're not, then you got some work that you need to take care of. Okay, look at the coefficients. If I add 2x and 3x, those don't cancel out. But check it out, y plus negative y, those do cancel out. So here's going to be the easy part. 2x plus 3x gives me 5x. And y plus negative y is just 0. So the y's cancel out. And that's what you want to do with elimination. You want to cancel out one of the variables. Okay, 7 plus negative 12. Don't forget, we're adding the equations. 7 plus negative 12, it gives me negative 5. So my equation is 5x equals negative 5. Of course, divide both sides by 5. X equals negative 1. So now I have x. I'm not done. I need to go back and find my y value. Now, it doesn't really matter which equation you go into. You can do it into either equation. I'm going to go ahead and do equation number 1 because that's a positive y. I don't really need to do too much steps. But you could definitely use equation 2. I'm just going to use equation 1. So I have 2x plus y equals 7, right? And in that parentheses, I'm going to put my x value that I found out was negative 1. So now that x is negative 1, 2 times negative 1 is negative 2. Negative 2 plus y equals 7. Add 2 to both sides to get rid of that 2, negative 2. And I get y equals 9. So now my solution, and be careful with this, your solution is going to be negative 1 comma 9. It should be x comma y. All right, should be in that format. All right. Now we're going to go on to some ones that aren't quite like this, right? Notice there's none that cancel out. Okay. I'm going to go ahead and line them up. My x's line up, my y's line up, my constants line up. Constants are on the other side of the equal symbol, so we're good to go. Now, if I notice something here, 4x and x is going to give me 5x. Negative 3y plus 5y is going to give me 2y. So nothing's really going to cancel out. So in this situation, I got to choose by multiplying one of the variables by a number so that it changes the second equation. And thankfully, I'm going to start with this coefficient right here of 1. So I'm going to change equation number 2. I'm going to get a new equation. And I'm going to take equation 2, and I'm going to multiply the whole thing times negative 4. The whole equation times negative 4. And the reason being is because when I change this coefficient to a negative 4, that's going to give me that negative 4 that cancels out when I add with that other 4x. So negative 4 times x gives me a negative 4x. Negative 4 times 5y gives me a negative 20y. And 39 times negative 4 gives me a negative 156. Okay, so now I can kind of get rid of this equation. I'm not really going to use it now. I'm going to use this new equation. I'm going to go ahead and call this 2a, right? It's a new equation. And then I'm going to add this equation, equation 1 and equation 2a. All right. Well, 4x plus negative 4x is 0x. It gets rid of the x, and that's what the whole process of elimination is. Okay, then I have negative 3y plus negative 20y is negative 23y equals, and then negative 28 plus negative 156 gives me negative 184. Okay, then I have to divide both sides by negative 23. And I get y equals 8. So see, I'm still going to get an equation. I still get a variable. The great thing about this is I can plug this value of y into any of these equations. It doesn't matter which one I use, right? The y is solved. So I'm going to go back to this 2, this equation 2, because the x is already there. It's going to be really nice. So I have x plus 5 times y, so parentheses, equals 39. Now remember, I'm using my original equation 2. So in that set of parentheses, I'm going to put my y value, which gave me 8, and then I just multiply right there. Right? Okay, 5 times 8 is 40, so x plus 40 equals 39. Subtract 40 to both sides. X equals negative 1. So now I have x and a y. Negative 1 comma 8 is my solution. Now, in order to test these solutions to make sure that they're 100% correct, what you can do is you can plug this x and this y value into these equations to tell if they're true. Okay, to see if you get a true statement. And so what I'm going to do is I'm going to take equation 1. I'm going to plug the x and the y value in. So 4 times negative 1 minus 3 times y, which is 8, should give me negative 28. If it doesn't, I did something wrong, right? Okay, so 4 times negative 1 is negative 4. Negative 3 times 8 is negative 24. Negative 4 minus 24 is negative 28. We're good to go. That's true. Okay, now the real test. I need to do the second equation, right? So x, which is negative 1, plus 5 times y, which is 8, should be equal to 39. Well, 5 times 8 is 40. Negative 1 plus 40 equals 39. I'm good to go. And that's how you check to see if this is a correct solution. This is how you verify. You don't have to do this all the time, but if you want to check and make sure, this is a simple way for you to verify that that is in fact the true answer. Make sure that all that work doesn't go to waste, right? Okay, number 4. Again, line them up, make sure that we're good to go. Unfortunately, none of these are going to cancel out. 2 plus 7 is not 0. Negative 9 plus 3 is not 0. So none of those are going to cancel out. But if you notice, there's something you want to pay attention to is the coefficients, right? I'm going to go ahead and mark this off. This right here, if you notice the y, that's kind of a multiple of this equation, right? 9 and 3, they go hand in hand, unlike 2 and 7. 2 and 7, you'd have to multiply each other. You'd have to multiply both equations because 2 and 7 don't, 2 doesn't go into 7 and 7 doesn't go into 2, right? Here, 3 goes into 9, so you would only have to multiply equation number 2, which is great. So, since this is already a negative 9 and this is a positive 3, I don't need to change the symbols. I just need to multiply. So, I need to multiply everything, right? Equation 2, I need to multiply that times 3, the whole entire thing, so that I get a new equation 2. Okay, so 3 times 7 is 21x. 3 times 3y is a positive 9y. 3 times 13 is a 39. So now I have this new equation 2a that I'm going to use. Okay, now I'm going to kind of put this equation on the back burner, right? I don't really need it now. Now I'm going to use equation 1 and equation 2a, right? And I'm going to go ahead and I'm going to add those two equations. So 2x plus 21x gives me 23x. Negative 9y plus 9y, guess what? Cancels out. Goes bye-bye, right? Okay, and then we have negative 85 plus 39. And that gives me negative 46, right? Real easy peasy. Then I take my 23, I divide everything by 23, and I get x equals negative 2. All right, so I have the first part of my solution. Now I got to go in and find my second part of the solution. And I can use either equation. Doesn't matter, okay? You notice here, I used equation 2. I'm going to go ahead and use equation 1 here. Just so I show you that it doesn't matter which equation you use. Okay, so x is negative 2, so it's going to be 2 times x minus 9y equals negative 85. Okay, in that value of x, I'm going to put a negative 2. 2 times negative 2 is a negative 4. Negative 4 minus 9y equals negative 85, right? Add 4 to both sides so that I can start to solve. I get a negative 9y equals a negative 81. Divide both sides by negative 9, and I get y is equal to positive 9, right? Negative divided by a negative is a positive. So there's my second part of the solution. Again, make sure that when you have your solution that you put it XY format. So my solution should be negative 2, 9. And again, you can do just like we did in this last problem. I'm not going to do it because I'm running out of space. But you can always go back, plug in the x and y, and see if you get a true statement for both of those to verify. Now we're going to talk about these special cases, okay? These special cases right here. Line them up. They all line up. That's good to go. So I don't need to do any extra work. In this case, 3x plus negative 3x. I can add these. Something will disappear. But look what happens when I add the whole equations. 3x plus 3x plus negative 3x is 0x. So that goes away. 3y plus negative 3y. Oh, that goes away too. And then 6 plus 5 equals 11. So I'm left with 0 plus 0 equals 11, or in other words, 0 equals 11. And that is a false statement, right? If you believe that 0 equals 11, I will give you $0 for your $11, right? Okay, so that's a false statement. What this is indicating and that there's no solution. Now, look what happens because there's no solution. Just like we said earlier, right? All the variables cancel out. The x's cancel out, the y's cancel out. And now I'm left with a false statement. There's my false statement. This means no solution, okay? You know what? I need to change this. That's what I meant to do. I apologize. I should have changed this to a -2. And I'm going to do that on your notes. So I wanted to make sure I did it on this note. So I'm going to go ahead and change this to a -2. On your notes, when I print it to you, I'm going to change it for you. Okay, line them up, line them up, line them up. Make sure they add x's, x's, y's, y's, constants, constants on the opposite sides. Very good. Okay, so I add my equations. -4x plus 4x is a 0x. -6y plus 6y is a 0y. -2 plus 2 is 0. So I have 0 plus 0 equals 0, right? All of the variables canceled out again. I'm left with the statement 0 equals 0. Guess what? This is a true statement. So because this is a true statement, that means that I have IMS, infinitely many solutions. In other words, these two equations are exactly the same. They're right on top of each other, right? So that's how you solve equations by using elimination.